right, we're on our Unit 6 Mid-Unit Assessment Study Guide, page 1. And you may use a for-function or scientific calculator on this, but not a graphing calculator, all right? So number 1, we have before we go over number 1, we have 3 pages and 7 questions that help us prepare for this test that we're going to be having on the middle of Unit 6. So number 1, a scale is balanced. So we need to draw a balanced scale. And on one side, we have a 3-gram weight and 4 identical trinkets. And then on the other side, we have a 10-gram weight. So I'm going to go ahead and put a 10-gram weight right here on one side. And then on the other side, I have 4 identical trinkets, but it doesn't tell us how much they weigh. And then we also have a 3-gram weight right here. Now, draw a picture to set that up. Well, here's our picture. Went ahead and helped you out with that. Now we need to set up an equation to find the weight of one trinket. So go ahead, pause the video right now. Give yourself an opportunity to set up that equation, and I'll be right back. All right, now that you've given yourself a chance to set up that equation, we have 4 trinkets, which I'm going to represent with an x. So 4x plus 3, because that's the 3-gram weight that we have right here, and it's equal to the 10-gram weight that we have on the other side. The opposite of adding 3 is to subtract 3. Again, we could subtract or add right away simply because we don't have parentheses. So then we're left with 4x equals 7. And then we need to divide both sides by 4 to find the weight of one individual trinket. And when we find that x, or one trinket, weighs 7/4 of a gram, or if in decimal form, 1.75 grams. Now, as we move on to number 2, we have select all the stories that represent the tape diagram, or that can represent the tape diagram. Well, first thing, we look at the total, which is 87. So we're looking for something that has a total of 87, and they added 39, and then of course they have 4 individual equal parts right here. So before you go read through that, how I would set up the equation for this would be 4x plus 39 is equal to 87. So go ahead right now and read through A, B, C, D, and E. Tell me what you think or which one would be correct, if not multiple correct options, and I'll be right back. So letter A, there are 87 children and 39 adults at a show. The seating in the theater is split into 4 equal sections. Well, to me, that is 87. And we have 87 children plus 39 adults. But then we're going to have to split that up into 4 even parts. But 87 plus 39 is going to give us a total greater than 87. So that isn't possible. Letter B, there are 87 first graders in aftercare or after school care. Now, after 39 students were picked up, the teacher put the remaining students into 4 groups for an activity. Well, we have a total of 87. We lost 39 students because their parents picked them up. And then the teacher was able to break them up into 4 equal groups, which matches up with the tape diagram below. So that is correct. Letter C states Lynn buys a pack of 87 pencils. She gave 39 to her teacher and shared the remaining pencils between herself and 3 friends. Though if she counts herself in that, she broke them into 4 equal groups, and she gave 39 to her teacher, which matches up with our total of 87. Then letter D, Andrey buys 4 packs of paper clips with 39 paper clips in each. Then he gives 87 paper clips to his teacher. That isn't a total of 87. 39 times 4 is going to be greater than 87. And then they were subtracting 87 instead of 39. So that's not going to work right here. Letter E, Diego's family spends $87 on 4 tickets to the fair and $39 for a dinner. Well, the total money spent would be 87 plus 39, which unfortunately is going to be greater than the $87 or the 87 total that we can afford or have with our diagram up above. So B and C are your correct options. All right, number 3, the cost Y for a phone plan is $15 for each gigabyte of data used, X in addition to a $30 per month flat fee. Write an equation for the monthly cost of the phone service. Then find the cost for 0 gigabytes, 1 gigabyte, and 6 gigabytes of data. So first we need to set up an equation. We're looking at y equals kx. Hopefully that sounds very familiar for you. If not, please send me a message on Remind, Canvas, because we need to break down y equals kx as we've gone over it in a couple units prior to this. So our equation we're going to set up is $15 per gigabyte, which we're going to represent with an X. Then we're going to add $30 per month right off the top because that's a flat rate to have this. And then that's going to equal our Y. So our cost per month. Now, the first one, we just want to plug in 0, 1, and 6 in our X right here to be able to determine how much it's going to cost us to have this plan depending upon how many gigabytes of data we use in that month. So the first one, we're going to plug in 15 times 0 because we didn't use any gigabytes right here, plus the $30. Well, 15 times 0 equals 0 plus 30, so it's going to cost us $30 per month regardless if we use any data. Then our second problem here, we're going to plug in 1 gigabyte, so we're going to go 15 times 1, which will give us 15. We're going to add the 30, so 15 plus 30 equals $45. So it's going to equal $45 to go ahead and try to use 1 gigabyte on this plan. Now the sixth option here is the 6 gigabytes of data. So we're going to go ahead and plug that in for X. So 15 times 6, and that actually gives us 90. So 90 plus 30, and that's going to set up $120 for us that month. So just to recap, we have our equation that we set up right here, which is 15x plus 30 equals y. And then we just substitute in the number we want to determine how much it's going to cost that much. So the first, we use 0 gigabytes, then we use 1 gigabyte, and then we use 6 gigabytes. For 0 gigabytes, it's only $30. 1 gigabyte, we add $15, so it's going to be $45 total. And then lastly, if we use 6 gigabytes of data, we're going to pay $120 for that month. Number 4, so we're moving on to page 2 here in our mid-unit assessment study guide. We have solve each equation. First, we have 16 minus 4x equals 48. And then we have 1/5 x minus 3 in parentheses equals -2. So go ahead, pause this video, go ahead, try to work that out for me, and we'll be right back. Now, in our first one, we'll call this one A, and we'll call that one B. In A, we don't have any parentheses, so we could add or subtract right away. Well, we want to isolate the variable, so I'm going to get rid of this positive 16 by subtracting 16 from both sides. And I am left with a negative 4x is equal to, so that's a 16 up there, is equal to 32. Well, then I need to divide both sides by a negative 4, isolate x, and we get x equals 32 divided by negative 4, which reduces down to -8. So we find the answer solution for x here is -8. On number 2, we have to decide, are we going to distribute first or are we going to divide first? I'm going to go ahead and divide. So I'm going to divide both sides by 1/5. That cancels out. But again, I'm dividing with fractions, so you should automatically be thinking of keep, change, flip. So we're going to keep our 2, but we're going to put it 2 over 1. We're going to multiply it now, and we're going to flip the fraction that we're dividing by to 5 over 1. So 2 over 1, negative 2 over 1 times 5 over 1 equals negative 10 over 1, which reduces just down to 10. So now we have x minus 3 equals negative 10. From there, we need to add the 3 to both sides because that's the opposite of subtracting 3 right there. Those cross out, so then we're left with x equals negative 7. So that is our solution for problem B on number 4. So number 5, Andrey tried to solve the equation 1/3 parentheses x minus 3 is equal to 4. What was his mistake? Find the correct answer. So they're asking us 2 things right here. We need to go through Andrey's steps over here and decide where he messed up at, and then we need to do it correctly to solve for our solution. Well, go ahead, pause it, try to solve or figure out where he messed up, and then solve for our solution. Well, when you're ready, go ahead and press play. I noticed that he made a mistake on his second step. When we're dealing with parentheses right here, we can either distribute or we could divide, but we can't add or subtract right away. And that was exactly what he did. Andrey's mistake was adding 3 to both sides. So we need to go, now that we found Andrey's mistake, we need to figure out what the solution to this problem actually is. So let's start by rewriting the problem. We have 1/3 times x minus 3 is equal to 4. Now, what we want to do, I'm going to go ahead and distribute first. And I know we're going to get a 1/3 x, and minus, and then, well, 1/3 of 3 is going to be 1. And so 3 times 1 right here is going to give us a negative 1, or 3, sorry. And then 3 times 1 right here is going to give us 3. 3 over 3 reduces down to 1. And we had negative, so we're going to keep it like that. And we have 1/3 x minus 1 is equal to 4. Now that we got rid of the parentheses by distributing, we could go ahead and add or subtract. We're going to add the 1 to isolate the variable to both sides. And we get 1/3 x is equal to 5. Now when we divide by a third, 1/3, boom, cross that out. Again, we're dividing by 1/3. We need to be thinking keep, change, flip. So let's send that up. We're going to have 5 times 3 over 1. So it's going to be 5 times 3 is 15. 15 over 1 reduces down to 15. So x is equal to 15, not 21. So there's our correct answer for number 5. Number 6, there's going to be part A, B, and C. So for each story, write and solve an equation, then explain the meaning of your solution in context to the problem. Letter A, a family buys 6 tickets to a show. They also pay $3 for a parking fee. They spend $27 to see the show. Part B, Diego has 27 ounces of juice. He pours equal amounts for each of his 3 friends and has 6 ounces left for himself. Part C, Jada works for 6 hours preparing for the art fair. She spends 3 hours on a sculpture and then paints 27 picture frames. This is actually a problem that we've done earlier in the unit, but I want you to be able to set up the equation for each, then solve for the variable, and tell us what that means in context to that story. All right, for our family who buys 6 tickets to a show and they also pay a $3 parking fee, they spend $27 to see the show. Well, I set up the equation with 6x because we don't know how much each ticket was. And then they also spent $3 to park. In total, they spent $27 to see the show. So we need to be able to break down the 6x somehow to find each individual ticket cost. Well, the first thing we need to do, since we don't have parentheses, is to isolate the variable. So we subtract 3 from both sides, and we find that 6x is equal to 24. Now, once we have 6x equals 24, we need to go ahead and divide by 6 to find out the cost of one ticket. Well, x is equal to 24 over 6, which reduces down to 4. Now, it isn't just good enough to find the variable or the solution here. We need to be able to put it back into context for that scenario or story. Well, we have 4. That means each ticket cost $4 for the family to buy. So just being able to say each cost or each ticket cost $4 is a big part of applying our math into a real story. Let's go ahead and look at letter B. We have 27 ounces of juice in total. He pours them out for 3 friends and he has 6 ounces for himself. So we need to figure out how much he pours for himself. Well, he poured 3x for his friends. We don't know how much. And then he pours 6 ounces for himself, and it's equal to 27 total ounces. Now, how we solve this is we don't have any parentheses, so we could go ahead and subtract 6 from both sides, and we find that 3x is equal to 21. Bring that back up. Now, we have 3 friends that we poured 21 ounces for. In order to find out how much we poured for each friend, we need to divide by 3. Find the ounces for one friend, and x is equal to 21 over 3, which reduces down to 7. And again, just finding that x is equal to 7 isn't good enough. We need to be able to put it in context to the story. So Diego poured each friend 7 ounces of juice. I apologize for my sloppy handwriting. Hopefully the notes that I send out will be a little bit better, but we need to be able to make sure that we put each of our solutions into context to the story. Then letter C, we have Jada works for 6 hours preparing for the art fair. Well, we know she spent a total of 6 hours. She spends 3 hours on a sculpture. So whatever she did, she added 3 hours, or half her time was working on the sculpture. And in the remaining time, she painted 27 picture frames. We don't know how long she spent working on each picture frame, so that's why we're going to represent it with X, so we could figure out how much time she spent on each of those 27 picture frames. Well, the first thing we get to do is to subtract 3 from both sides because she spent half her time working on a sculpture. So 27x is equal to 6. Then we bring that back up. More room to work here. 27x is equal to 6. Then we need to divide both sides by 27 to see how much time was spent. Whoops, I'm sorry, I forgot to making mistakes over here. 6 minus 3 is 3. So make sure you don't just copy that down wrong. So we should have 27x is equal to 3, not 6. So 27x, we divide 27 by 27 on both sides to find out how long she spends on each picture frame. Well, you could say x is equal to 3 over 27, but that also reduces down to 1/9. Either one of those would be acceptable. And so here is your solution of x equals 1/9. However, we need to be able to put that into context of our story. So Jada spends one-ninth of an hour on each frame. And this one in particular is extremely important that we leave it in fraction form, because as soon as we start rounding and converting over to hours and we have a decimal form, we get an imprecise answer, and it's going to lead us astray if we need to do something with that amount of time. Because maybe later on, for another client, she needs to be able to paint 52 picture frames. Well, we know it's 1/9 of an hour, and that's important to keep in mind because that's exactly the amount of time that she worked on each picture frame. Now, number 7, we have part A, B, and C. So for a party, Addie Rose will be renting a bounce house. The cost of the bounce house is a one-time fee of $79 in addition to $15 for each hour it is used. So part A, we're going to complete the table, giving the total cost for Addie Rose to rent the bounce house for 0 hours, 1 hour, 4 hours, and 6 hours. So we need to be able to set up an equation to plug those hours in for X. Then part B, write an expression for the cost of renting the bounce house for H hours. So even though for part A, you could kind of think critically and reason out the answers for 0 hours, 1, 4, and 6 hours to rent that bounce house, part B, we actually have to set up that expression. And then C, what is the maximum number of hours Addie Rose can rent the bounce house with a budget of $200? Explain your reasoning. Go ahead, pause the video, work out part 7, part A, B, and C as best you can, and I'll be back shortly. All right, so we need to be able to complete the table, giving the total cost for Addie Rose to rent the bounce house in part A. Well, we know it costs $15 per hour, and then the one-time fee of $79. So we have 15x plus 79 is how I think of that. Well, that's also going to help us later on in B. Well, 15 times 0 is 0. 15 times 0 is 0 plus the 79, and that's going to give us $79 regardless if we use it or not. So 0 hours, $79. Then we have 15 times 1, which gives us 15. Then we have to add the $79, and that's going to give us a cost of $94 per hour, or not per hour, but for that usage, 1 hour plus the flat fee. Then if we want to use it for 4 hours, we have 15 times 4, which equals 60. We're going to add that to our 79, and 60 plus 79 now gives us a total of 139. So $139. Then if we want to use it for 6 hours, we go 15 times 6 plus 79, and that's going to give us 90. So 79 plus 90 gives us a total of $169. And that's how we go about filling out that table. Now, write an expression for the cost of renting the bounce house for H hours. Well, I know it's $15 per hour, so I'm going to put an H, and then I'm going to put 79 for a flat fee. So we'd have 79H, or 15H, I apologize, plus the 79 is our expression. If we wanted to set it up in an equation, I could write 15H plus 79 equals our cost. So C. Then part C, we need to be able to write in or use that expression and convert it into an equation where we set it equal to 200, because $15 an hour plus our $79 fee, and we have to set it to $200. The reason we set it to 200 is because that is our budget right here. So budget of $200. Now, we don't have parentheses, so we could go ahead and add or subtract. We're adding 79, so the opposite is to subtract 79 from both sides. And then we get 15h equals 121. And then we need to go ahead and divide both sides by 15 to figure out how many hours we could actually rent this bounce house for. And we get h equals 8 1/15. Now, if we only have $200 and the bounce house rental company will only rent it to us by the hour and not in 15-minute increments or by the minute, we're only going to be able to spend enough money to get 8 hours because we don't have enough to bounce up to the full 9th hour. So that's not going to work for us. So 8 hours is how long we could actually rent this for. Addie Rose could rent it for. So again, we found out our solution. If we have $200, it's 8 1/15. However, the company only wants to rent it for a full hour. So thus, Addie Rose can rent the bounce house for 8 hours. So I highly recommend going over this study guide. We've completed everything we need to. Study it up. Make sure you're decently confident with it. Make sure you're good at finding solutions for the variables, whether it's a negative or a positive, and putting it back into context of the story for us. All right, I wish you best of luck on the mid-unit 6 test. It'll come up and it'll be open here shortly.